Welcome back everyone, Energy Fabricator here. I've just returned from the local scrap metal yard that I usually go to scrap out all my steel, and I've done a bit of a deal with the guy. He's allowed me to fill up a 20 litre bucket full of pretty much whatever I want, as long as it's not steel. I can take any sort of electrical components or anything like that I need, and it's only going to cost me $5, so 20 litres of whatever I want for $5. I think that's a pretty good deal. Let me show you what I got on the first bucket. The first thing I found was these Emi filters, so I stripped them out of a UPS. These are fairly chunky. You can see the gauge on the wire, it's pretty heavy gauge wire. A lot of current flowing through these, so they might find a use in my black box that I'm building. So that will definitely be a handy piece of kit. I also have a whole bunch of DC plugs here and some terminal blocks. I've got a couple of those, 2 of those, 3 of those DC terminals, another terminal strip here, fuse holder, a 7 amp, 250 volt AC resettable fuse. I also got a couple of these transistors which belong over there. Found some shunts. These ones here are 75 millivolt 5 amp. This one here again 75 millivolt 10 amp, and then I've got a 50 millivolt 20 amp shunt. So there's 3 of those. Got a couple of fuses here that I found. I also have a bunch of diodes here that I stripped out. So they're all ready to go. They look in pretty decent condition. If I can get that to zoom, a BTW40 is what we're looking at there. I don't know if that's all you need, but there you go. I got a handful of those. Also got these terminal protectors for these plug-in terminals. Also picked up a whole bunch of these little cable identification tag things that just clip on, so I'll pull all of these off and I'll probably end up using those in my black box. I also found this little capacitor bank in the UPS. These are rated at 450 volts DC, 3,300 microfarad each. You can see they're joined up in series there. And I also got a whole bunch of DIN rail mounted terminals here, and over here this is more DIN rail mounted stuff here. Won't even bother going through what it all is, but pretty cool. These are cool because they're just 3 massive fuse blocks. You can see the fuses are in there. Actually, there's no fuses in that one. There we go. In this one here, you can see the fuses poking out. So they'll probably end up in the black box. These won't be in the black box, but they'll come in handy nonetheless. Just more Emi filters. I've got 3 of those. Above here I've got 7 telemechanic contactor blocks, and I also found some of these motor switches here as well. I've got 3 of those. A couple of inductors, some relays, bunch of capacitors. This one's here. This one's rated at 900 volts DC, pulse rated. Some transistors, and I also found 6 200 ohm 40 watt resistors. So they're pretty chunky, coming useful one day. And the last thing I found was these battery plugs here, these battery terminals. Never seen anything like it before, but if I find the other mating half one day, these might come in pretty useful for some sort of high current DC connection. Got the old high voltage warning sign, a few diodes, a few rectifiers. These ones are pretty old school. You can see they've just got 4 diodes, potted them in this housing and joined them together to make a full-on rectifier. Old school. The terminals are a bit worn and rusty looking, but after a bit of a clean up they'll be fine. So I've got 3 of those and a slightly newer model. There you go. So that's pretty much everything I've got here. All of this stuff was in my 20-litre bucket for $5, so I'm pretty happy with that. Some pretty good bits and pieces, and it should all be pretty useful at some point in time. Now, the other thing I found recently was this book. It's called the Hawkins Electrical Guide #1. It's a 10-part series. This is the first book. I paid $20 for it, but it's well worth it because it's an old book that was written in the early 1900s, and this first book contains all the information that I wanted anyway. The other 9 books don't really apply to what I'm doing and don't have anything that I'm interested in on the inside anyway. So if we open it up, you can see it's pretty old school. It's got a picture of Thomas Edison on it. It covers everything from static electricity, current, magnetism, dynamos, induction coils, electromagnetic induction, motors, AC and DC, field magnets. Covers pretty much everything in relation to basic electricity, and there's a lot of diagrams on the inside on how things work, how things interact, and basic experiments that you can do to see it all for yourself. It's in somewhat of a question and answer format, but as I said, there's a lot of diagrams showing you field interaction lines and all sorts of stuff. There's a lot of work on static electricity here as well. Condensers, capacitors, batteries, you name it, it's in here. So as I said, pretty cool book. There's a lot of stuff in here that you won't find in textbooks, but still current nonetheless. But yeah, so that's a pretty awesome little book. I'm pretty happy to have found that. It's in awesome condition. None of the pages are bent or torn, and the cover is still in one piece, even the back. So I'm going to look after it and see if I can keep it for some time now. I've already referred back to it a few times, so I'm very happy with that. I was at a company a while back and they were throwing out a whole bunch of display stands, so I stripped these 20mm thick pieces of acrylic off the display stands and took them with me because I'm sure I can cut some parts out of that for some vacuum chambers and all sorts of other stuff. So I've got a whole stack of them here, all bubble wrapped up, keep the faces nice and fresh, scratch free. So yeah, that was pretty cool. This stuff's pretty expensive when you get to the 20mm thick range and above, so to get that for free, all I had to do was strip it off their steel frames. I recently picked up this Warburton Franke 20MHz oscilloscope. It's a 2-channel, it's an analog one, and it's working perfect. It's fully calibrated, nothing wrong with it, so that'll be very useful. I only picked it up for $50, so you can't go wrong. As you can see here, I've got a couple of glass bottles of Boss water. I found a couple of these old fittings in my parts box, and they've got a bit of an O-ring that you can see just on the inside there, and what I've done is mounted an 8mm quick connect fitting to the top here, and that just literally sits, if I can get that to zoom for you, that just literally sits on the lip of the glass bottle. When we vacuum it down, that will hold on by itself and form its own seal with the O-ring. So now we have a glass bottle vacuum chamber. We can actually isolate it using this isolation valve here, and then completely remove it from the vacuum line, and then walk away with a vacuum chamber and do whatever we want with it. I've done that there, and I've also done it with this one here. This one's a little bit more elaborate because of the fittings that I had to use, but it does the same thing. I've got the little red stop plug at the moment sitting in this 6mm quick connect fitting. Then I've got this brass end cap screwed into this stainless steel fitting here, which is a KF flange fitting, and then I've got the KF flange assembly going here, and then that just slips into the top, and I've got another vacuum chamber here which we can isolate and do whatever we want with it. So there you go, we've got a smaller one and a big brother. That's the old power supply that I made for my old bipolar Tesla coil. I've had to strip it down because I needed to get the variac out of here. I needed the DC terminals and a few other bits and pieces for my black box, and I also needed the switch out of it for my friend Electro, who needs one for his cell, his HHO cell that he's making. So there's two of them that I have. Now, Electro, I think I might send you this one here because this one looks more like the size that you need. But let me know how long that toggle there is, just this piece here, from here to the base, and I'll send you the more appropriate one. This one here is rated at 10 amps and the toggle's pretty big. This one's somewhat smaller. So I think that one looks more like the size that you'd need, and it's a bit smaller on the housing, so I'm thinking the rating on the current should be about the same. If you want both of them, let me know, I'll send you both of them, but they are slightly different. This one's a bit bigger. So there you go. So I'll send that to you, plus the wire, that'll come out to you as well. Just send me your address. The other thing I found was this black powder coated steel frame. I'm going to use that to mount my vacuum pump there, and the manifold and a bit of a switch and all sorts of stuff, so that'll be a portable little vacuum stand. The black box is looking pretty dormant at the moment. I've made a few changes. As you can see, I've flicked these rails around the other way so everything's facing outside towards the back, so I can do easy maintenance and checking and switching and repairs. I've also put right at the bottom there, you can see the aluminium panel with the output plugs, because I didn't want to have them on the front side with all the controls, because I'd be tripping all over high voltage, high frequency cables every time I went near this thing, so I put them on the back. As you can see, all the face panels have been removed. Everything's been torn down. The variacs are just sitting on the base at the moment, and all the other parts have been put away into boxes, and I've got an old painting drop sheet covering it up sort of, but it's all happening, and within a few weeks I should have the whole face back and fully assembled, and then we can concentrate on ballasts and then the wiring. Now, leaning up against the cabinet there, you can see all of these aluminium panels. These are all of the face panels for the black box, They are all 100% complete, all drilled out, sanded, corners have been rounded, edges have been deburred, holes have been deburred. I've taken it down to about 400 grit roughly. Still need to give it a sand at about 600 grit and then 1000 grit, and then I will be polishing them by hand as well, and then I can take them down to the anodizers next week. I want to get them as shiny as possible, which is why I'm going down to 1000 grit and then hand polishing them, because when I take them down to get anodized, they will lose a bit of shine when they give them a quick etch before they do the anodizing, so I have to be above and beyond the level of shine that I need so that when I get them back, as well as being black, they're nice and shiny as well. But they're all 100% done. I've done a full trial assembly and stripped it down, so when it comes back I'll know everything will fit perfectly. If anything, it'll be a bit looser because the etching and anodizing will open up the holes ever so slightly. But yeah, looking forward to getting that done and getting them back, and then it's just a case of wiring everything up. I've got pretty much everything I need minus 5 ballasts, but we can still move on regardless that we don't have those anyway. I also picked up this 1 farad capacitor. It's rated at 20 volts DC, and it's one of those car audio capacitors. So for $5 it's pretty chunky, holds a bit of charge. Just for a bit of a comparison, there's the Boss water bottles. It's about the size of a 1 litre bottle of water. Pretty chunky. Anyway, I'm sure I'll use that one day. What you're looking at here is 4 strings of UF4007 diodes. There's 50 of them in a string, so there's 4 50 kV high frequency rectifiers there. Got to finish them off, and I might even show you a quick clip of how I made them, just to show you how I kept the spacings exactly even while I did the soldering. I had to make a little jig, so it might come in useful for somebody else that wants to do a similar thing and doesn't want them to be different lengths when they're all finished. Want them to look neat and tidy. I'll show you that jig and how it all went together. Here is my little soldering jig that I made to solder all of these high voltage diodes together. And I've drilled a hole in the side here. One diode goes in that side, the other diode goes in that side, and then we can get our soldering iron into the middle here and solder those 2 wires together. And then once that's done, because it's all kept fairly straight, we can just pull it all through, and as one unit that'll just pull through from one side to the other, and then we can just continue that string out the end that way, and then just pop a new one in on that side there and just pull that whole assembly through. But that's pretty much how it works. It worked pretty well, and it kept the whole diode string to within 5mm tolerance on the overall length, so I'm pretty happy with that. And I just usually line it up so that the diode body actually sits flush with the inside there like that. And if we do that on both sides, the spacing between the diode bodies will always be exactly the same. So that's how I've managed to make them all at the same length. So there you go. It saves a lot of time as well. It's way better than those alligator clip PCB holder things. I was dicking around with that for a while and realised it was worth my time just to go out and make one of these things here. It does the job a lot better. I have also been playing with a ZVS driver, so my circuit that I've been working with is this transformer here. We've got the 240 volts AC coming in, up to 44 volts on the output. Obviously the transformer has been ballasted. This one's at 250 watts. The output of that transformer was going into this rectifier here. I had this capacitor on the rectifier as a DC smoothing cap. DC goes into the ZVS driver here, and the output came out to these three leads here. You can see everything's just stuck on there. Not very neat looking, but it did work. The output went over to this flyback transformer here, and I had the output leads up here. I've blown it up, so I'll be building a new one. I'll also be making a larger version. This is just a little quick test